70 centimeters, not a depth of snow, not the height of a wall, a core of lake mud, pulled from the bed of a small lake in southern Greenland in July of 2016. Inside it lay 2,000 years of continuous record, laid down season by season beside the ruins of a Norse farm in the eastern settlement. Nobody had ever sampled that ground before. Every climate reconstruction ever applied to the Greenland Vikings had come from ice cores drawn more than 1,000 kilometers to the north and more than 2,000 meters higher in elevation. This was the first measurement taken where the farms actually stood. What the core recorded was not what half a century of scholarship had predicted. For roughly 5 centuries, a European farming society existed at the far edge of the Arctic. Then it did not. Nobody ever wrote down the ending. The man who founded the colony had been exiled twice. Erik Thorvaldsson, called Erik the Red, came to Iceland as a child because his father had been driven out of Norway for killing a man. He grew into the same pattern. A dispute over borrowed timber ended with 2 of his neighbor's sons dead, and the Icelandic assembly sentenced him to 3 years of banishment. The direction of that exile was decided by geography. Norway was closed to his family, south was open ocean, west was a rumor. The saga's record that a sailor named Gunnbjorn Ulfsson had been blown off course generations earlier and glimpsed land on the horizon without ever going ashore. Erik sailed toward it in 982. What he found first was the eastern coast, an unbroken wall of ice and black rock that runs for hundreds of miles and offers nothing. He worked south, rounded the southern tip that later mariners would name Cape Farewell, and turned up the western shore. There the ice gave way to deep fjords, sheltered valleys, grass, seals along the water, seabirds on the cliffs. It was not Iceland. It was not Norway. But it was enough for a man with nowhere to go. He spent the full term of his sentence surveying it, and returned to Iceland with a proposal that required several hundred people to abandon everything and follow a convicted killer to a country none of them had seen. The sagas say he called it Greenland deliberately, because the name would attract settlers. Those sagas were written down more than 2 centuries after the fact, and the detail may be literary rather than historical. What is not in question is the result. Around the year 985, a fleet left Iceland carrying livestock, tools, and families. The sagas put it at 25 vessels, and only 14 completed the crossing. Some turned back. The rest were lost. The survivors established 2 settlements along the southwestern coast. They are confusingly named. The eastern settlement sat in the far south, near what is now Qaqortoq. The western settlement lay roughly 500 kilometers north of it, near modern Nuuk. At their height, the 2 together held perhaps 500 farms in the south and 100 in the north, supporting a population that current estimates place somewhere between 2,000 and 3,000 people. Erik claimed neither settlement. He took the single best property in the territory for himself, an estate called Brattahlid at the head of a fjord, with the finest pasture anyone had yet found, and built a hall there that Danish archaeologists measured in the 1930s at roughly 24 meters long. What the land gave them was narrow, and it never widened. There were almost no trees, which meant no timber for houses or ships. There was no workable iron ore, which meant no tools or weapons of their own making. Grain would not ripen reliably, which meant no bread without imports. Driftwood washing onto the beaches was valuable enough that community leaders rationed it and forbade its burning. For fuel, they cut peat, which Greenland had in quantity. For building, they used dry stone and turf, insulated with hide. Within a single generation, they had engineered a functioning Arctic farming society out of a place that supplied almost none of the materials a farming society requires. That is the achievement. It is also the vulnerability. Everything they could not make, they had to buy, and buying required something the rest of Europe wanted badly enough to sail 4,000 kilometers to collect. For most of the 20th century, the explanation was fixed. It appeared in textbooks. It appeared in documentaries. It appeared in the opening chapters of academic surveys. It was, by any reasonable measure, settled. The Norse, it was said, were rigid Europeans who carried their farming traditions into the Arctic and refused to put them down. They kept cattle in a place where cattle made no sense. They kept sheep after the grass had started to fail. They watched the Inuit hunting successfully across the same fjords and learned nothing from them, because the Inuit were heathens and the Norse considered themselves the better people. They starved to death with their European dignity intact. The argument has serious authorship behind it. Thomas McGovern, an archaeologist now at Hunter College in New York, wrote in the 1980s of a fatal Norse conservatism in the face of fluctuating resources. 2 decades later, Jared Diamond carried the case to a mass readership in his book, Collapse, where Greenland became the central parable of a society that chose its own destruction. It is important to understand that this was not a lazy conclusion. It followed the evidence that existed. The animal bone record from Norse farms genuinely does show cattle being maintained at latitudes where cattle are close to indefensible. No kayak has ever been recovered from a Norse context in Greenland. No toggling harpoon, the single most effective sea mammal weapon in the Arctic, appears anywhere in their material culture. The written sources that survive are European in outlook and consistently dismissive of the people they called Skraelings. And the outcome was not ambiguous. The Norse colony ended. The Inuit did not. When one population disappears from a landscape and another continues in it, the inference that the first failed to learn what the second knew is not unreasonable. It is the obvious reading. It was also a story with a moral attached, and the moral was clean. A civilization destroyed by its own arrogance. A warning about the cost of refusing to learn from people you consider beneath you. That is a satisfying shape for a story to have, and satisfying shape is usually the first indication that a story is doing work beyond description. The difficulty with overturning it was practical. There were no unread documents. The written record of Norse Greenland amounts to a handful of letters, a scattering of annal entries, a papal correspondence file, and 2 sagas composed centuries after the events they describe. That archive was exhausted by the middle of the 20th century. No archive was going to produce a second draft. Whatever revised the verdict on the Greenland Norse was not going to be found in a library. It was going to have to come out of the ground, or out of the bodies, or out of the sediment. And the instruments capable of reading those things had not yet been built. Those instruments arrived slowly, and they arrived from outside archaeology. The first of them was applied in a laboratory in Aarhus, and it required no new excavation. It required only the bones that had already been dug out of Norse churchyards and shelved for the better part of a century. The technique was called stable isotope analysis, and its premise was that a human skeleton is not merely a structure, it is a record. Every meal a person eats leaves a chemical signature in the tissue that person builds out of it, and that signature does not fade. The bones of the Greenland Norse had been carrying the answer the whole time. The mechanism is straightforward. Carbon and nitrogen exist in more than one stable form, and the ratios between those forms differ measurably between land and sea. A cow raised on Greenlandic pasture and a seal taken from a Greenlandic fjord carry different signatures. When a person eats either, the signature is incorporated into the collagen of their bone and fixed there permanently. Measure the ratios in a fragment of skeleton and you can determine with reasonable precision what proportion of that person's protein came from the water. In 1999, a team published exactly that measurement for the Greenland Norse. Jette Arneborg of the National Museum of Denmark, working with Jan Heinemeyer, Niels Linnerup, Henrik Nielsen, Niels Ruud, and Arne Sveinbjørnsdottir, examined 27 skeletons excavated from Norse churchyards, spanning the late 10th century to the middle of the 15th. The results were published in the journal Radiocarbon. At the beginning, the bones show what the traditional narrative predicts. Around the year 1000, in the generation of Eric the Red, roughly 20% of dietary protein came from the sea. 80% came from the land. Beef, mutton, dairy. The food of a European agricultural society transplanted north and holding its shape. By the final generations of the colony, around 1450, the figures had inverted. Roughly 80% of the protein was marine, most of it seal. The proportions did not shift. They reversed. That measurement was extended in 2012 when Earl Nelson, Heinemeyer, Linnerup, Svein Bjornsdotter, and Arneborg published an isotopic analysis of 80 individuals drawn from 7 churchyards, 5 in the eastern settlement and 2 in the western. The larger sample confirmed the pattern and gave it resolution across the colony rather than a single site. A society that refuses to adapt does not rebuild its entire protein base from the ground up. That is not what conservatism produces. That is what a population under sustained pressure produces, generation after generation, teaching its children to hunt what its grandparents had barely eaten. The evidence is not without complication, and the complication deserves stating. The animal bone assemblages from some excavated farms, notably the site known as the Farm Beneath the Sand in the western settlement, do show increasing exploitation of marine species, but not a shift of the magnitude the isotope data implies. Reconciling the two records is an active problem. Arneborg's own framing has always been more careful than the headlines that followed it. The Norse could adapt, she has argued, but there was a limit to how far they could adapt while remaining recognizably themselves. Their diet moved toward the Inuit diet. The distance between the two societies remained too great for the Norse to become Inuit. The isotopes prove effort. They do not prove that effort was sufficient. The wider archaeology tells the same story in a different language. Equipment for hunting sea mammals increases in the record of the later phases. Farmsteads consolidate. Outlying properties at higher elevations closest to the ice are given up first. At Cor Lor Tor Suak in the eastern settlement, a farm was abandoned and downgraded to a seasonal grazing station as the ground it depended on stopped producing enough hay to carry livestock through winter. Everything the Norse could change, they appear to have changed. Which leaves a question the older narrative was never required to answer. If these people were adapting continuously across 4 centuries, abandoning the food of their ancestors, restructuring their settlements, and pushing their hunting further out each generation, then something else killed them. Something did. And the first place to look was not the weather. It was the ledger. The Greenland colony survived on one export, sold to one partner along one shipping route. Every summer, hunting parties sailed north from the settlements to grounds the Norse called the Nordersetur, in the waters around Disco Bay. The journey was long and the return was uncertain. What it produced was the most valuable raw material in medieval Europe: walrus ivory. European craftsmen had no reliable access to African elephant tusks, which made walrus the prestige material of the continent. It was carved into crucifixes, into bishops' croziers, into ornate book covers, into the chess pieces recovered on the Isle of Lewis. Walrus hide, extraordinarily tough and fully waterproof, was cut into rope strong enough to rig the largest ships afloat. Alongside it, the Greenlanders exported fox fur, seal oil, and polar bear pelts. Gerfalcons went south as royal gifts. Narwhal tusks were sold into a market that believed them to be unicorn horn. In return, ships from Bergen arrived carrying iron, timber, grain, weapons, communion wine, and altar candles. Without those cargoes, the colony could not function. What the ivory trade actually did to the Greenlanders was invisible until researchers began sequencing the waste. In 2018, Bastian Starr, James Barrett, Agata Gondek, and Sanna Boysenkool published work in Proceedings of the Royal Society B that traced medieval European ivory back to specific Arctic walrus populations for the first time. Their material was not the finished carvings. It was the rostra, the snout sections of walrus skull that held the tusks in place during shipment and were broken up and discarded in the ivory workshops of Trondheim, Bergen, and Dublin. 2 years later, Barrett, Bosanquist, Catherine Kneale, Tamsin O'Connell, and Starr extended the study in quaternary science reviews, examining 67 rostra dated between the 11th and 15th centuries. The late specimens differ systematically from the early ones. They are smaller. They come more often from female animals. Genetically, they belong to populations found further and further north along the Greenlandic coast. Barrett's term for the pattern is serial depletion. It is the standard signature of a resource being hunted out and pursued to its next refuge. How far they went was established only recently. In September 2024, Emily Ruiz Puerta and colleagues published genomic sourcing work in Science Advances, placing late Norse ivory in the North Water Polynia, the Pikiala Sorsuaq, high in the Arctic between Greenland and Ellesmere Island, and possibly in the interior Canadian Arctic beyond it. Their modeling puts the outbound voyage from the western settlement at roughly 30 days of sailing. Consider what that distance means. These were not men refusing to change their methods. These were men sailing a month north into some of the most dangerous water in the hemisphere, into grounds where Thule Inuit and late Dorset groups were hunting the same animals in the same seasons. The 2024 study argues that routine encounters between them were close to unavoidable and that some degree of formalized exchange became increasingly likely. They went further and worked harder for less, because the market was closing behind them. Expanded Mediterranean trade restored European access to African elephant ivory across the 13th century, and fashions moved with it. Prices for Greenlandic walrus eroded across decades rather than collapsing in a single season, which gave the colony no clear moment to react to. There is little evidence of walrus ivory reaching mainland Europe at all after 1400. Barrett's phrase for the outcome is a resource curse, one that undermined the resilience of the colonies. The single lever that had purchased 4 centuries of iron and timber and grain stopped moving. The climate explanation had a problem that took decades to become visible. It was not that the data were wrong. It was where the data came from. For most of the modern period of research, the temperature history applied to Norse Greenland was reconstructed from ice cores drilled into the Greenland ice sheet. Those cores are extraordinary records. They are also drilled more than 1,000 kilometers north of the eastern settlement and more than 2,000 meters higher in elevation. Raymond Bradley of the University of Massachusetts Amherst stated the difficulty directly. Before this study, he said, there was no data from the actual site of the Viking settlements, and that is a problem. So they went and collected some. Between 2016 and 2018, Bradley, Isla Castaneda, Boyang Zhao, Tobias Schneider, and their colleagues took sediment cores from a body of water known as Lake 578, adjacent to a former Norse farm and close to one of the largest clusters of farmsteads in the eastern settlement. Nobody had studied that location before. The core they recovered was 70 centimeters long and held 2,000 years of continuous deposition. They read it with 2 independent markers. The first is a class of lipid called branched GDGTs, whose molecular structure varies with temperature in a way that can be calibrated and reversed. The second comes from the waxy coating on plant leaves, which records how much water those plants were losing to evaporation, and therefore how dry the growing conditions were. The results were published in Science Advances in March of 2022. There was no substantial temperature change across the settlement period. What the core recorded instead was a persistent drying trend, deepening across the centuries of Norse occupation and reaching its peak in the 16th century. The killer was not the cold, it was the drought. For this particular society, that is worse. Everything in Norse Greenland rested on hay. Hay is what carries livestock through a winter that no pasture can. Less rain produces less grass, which produces less hay, which means animals held indoors on stored feed that runs short before spring arrives. Fewer calves survive, herds contract. dairy production falls, and the following summer has to make up a deficit it was never capable of making up. Every farm in the colony entered the same compounding spiral at roughly the same time, and the drying trend in the sediment runs concurrent with the dietary shift recorded in the bones. The two records are describing the same crisis from opposite ends. The scale of the effect is not hypothetical. Drought in southern Greenland in 2008 cut hay yields by around half. Further drought summers followed in 2010, 2011, 2012, 2015, and 2019. Modern Greenlandic farmers respond by importing feed. That option did not exist in the 15th century. There is a second reversal alongside it. In 2015, Nicholas Young, Avriel Schweinsberg, Jason Briner, and Joerg Schaefer published cosmogenic dating of boulders left behind by advancing glaciers in southwestern Greenland and on Baffin Island. Their results place those glaciers at or near their maximum extent during the period of Norse settlement. The medieval warm period in Greenland was not warm, which dismantles the shape of the story. The Norse did not arrive in a temperate window and fail to notice it closing behind them. They arrived somewhere already cold, already marginal, already close to the limit of what farming could sustain. And then, across 400 years, it got drier. Zhao has been explicit that drought was never the sole cause. It was the ground shifting under everything else. While the pastures were drying, the sea was rising into them. The mechanism is counterintuitive enough that it went unmodeled until 2023. In that year, Marissa Boragine, then a doctoral candidate at Harvard, published work in the Proceedings of the National Academy of Sciences with Konstantin Ladachev, Sophie Coulson, Evelyn Powell, Jerry Mitrovica, Glenn Milne, and Richard Alley. Their subject was glacial isostatic adjustment, the way the surface of the Earth and the surface of the ocean respond to the growth and loss of ice. An advancing ice sheet does two things to the coastline beside it. Its mass exerts gravitational attraction on the surrounding water, pulling the sea toward it. Its weight presses down on the crust beneath it, and the land sinks. Boragine described the combination as a double whammy. The ground goes down while the water comes up. Sea level rises not despite the ice growing, but because of it. Applied to southwestern Greenland at roughly 1 kilometer resolution and compared against the archaeological map, the model produced figures that are difficult to absorb. Across the period of Norse occupation, sea level in the settlement region rose by up to 3.3 meters at a rate 2 to 6 times that of 20th century sea level rise. Around 204 square kilometers of coastal land were affected. Shorelines retreated by hundreds of meters. 75% of known Norse sites in the region sit within a kilometer of an area of flooding. At Brattahlid, Eric's own estate, earlier estimates put the loss of home field at around 50 hectares. The land that flooded was the best land they had. Flat, fertile, low-lying ground at the heads of the fjords. It was where the livestock had grazed for 400 years. The inland pastures were drying. The coastal pastures were drowning. There was nowhere for the farming to retreat to. Then the external supports were cut, one after another, inside a single lifetime. In 1349, the Black Death reached Norway and killed somewhere between half and 60% of the population within roughly 6 months. There is no archaeological or genetic evidence that plague ever reached Greenland. It did not need to. Greenland had spent 4 centuries building its entire external relationship around Bergen, and the merchant families, shipping crews, and trading agreements that constituted that relationship were destroyed in half a year. In 1378, Alf, the last bishop of Greenland, died at Gardar. No replacement was ever sent. The papal records contain later correspondence about the idea of appointing one, discussed with the detachment appropriate to a diocese nobody in Rome could reach. In 1379, the Icelandic annals record an attack in which 18 men were killed. The last dated event is a wedding. On the 16th of September, 1408, at Valsey Church in the Eastern Settlement, Thorstein Olafsson married Sigrid Bjornsdottir. Two priests, Eindridi Andresen and Paul Halvardsson, read the banns on 3 consecutive Sundays. The couple were Icelanders who had been blown off course to Greenland. They returned to Iceland and settled there. Radiocarbon dating indicates the colony continued for perhaps another half-century after they left. What happened in that half-century is not agreed. Some researchers read an organized, deliberate departure, a population that assessed its position and left. Thomas McGovern, who has worked on the problem longer than almost anyone, reads it differently. He calls it a real tragedy, the loss of a community of perhaps 1,000 people at the end, and uses a plainer word for the outcome. Extinction. Both readings remain live. Neither has been proven. When Hans Egede arrived in 1721 expecting a Christian settlement, he found stone walls and silence. The lake was there too, a few hours from the ruins he was standing in, holding 70 centimeters of mud that had been recording the answer for 2,000 years. The core did not change what happened. It changed which question we had been asking. For 5 centuries, the Greenland Norse stood accused of failing to adapt, and the charge held because the evidence to answer it had not been read. It was in the collagen of their bones. It was in walrus skulls discarded in European workshops. It was in the crust beneath the fjords, and in the sediment of a lake beside a farm that nobody had thought to sample. The question was never whether they adapted. It was whether adaptation was ever going to be enough.